Hi class, we're looking at lesson 7.2, the substitution method. This is a method for solving system of equations through substituting information from one equation into another to solve. This is probably one of the most complicated forms of solving systems, and it requires a lot of work, and you need to be very meticulous, especially with your math and your signs. So let's look at the first example and we'll go through it. So here you can see we have a system. We have negative 2x plus y equals negative 1. And then the second equation is 4x plus 2y equals 12. So what we're going to do is we're going to rearrange this first equation here into slope-intercept form so that it's y equals something, and it's going to be 2x minus 1. So we rearrange that into slope-intercept form. You don't necessarily have to use slope-intercept form. You could rearrange it into an x equals equation if it were easier. Always go with the easiest route. You don't want to, the more steps and the more complicated problems and the more complicated it is to rearrange it into that one variable, the more the chances that you'll make errors in your math are going to be increased. So you want to do the easiest one possible. So we'll rearrange that into y equals form, and then we'll substitute whatever y equals in for y in the second equation, okay? You want to make sure you put it in parentheses. That tells you we'll have to distribute things. Then we can combine like terms and solve for the variable. And in this case, we'll solve for x. Once we get x, we can plug x back into either equation and solve for y. And a good check is to plug them back into both and make sure you get the same answer. So let's look at the first example here and see how that's done. The first thing I'm going to do is I will rearrange that first equation into y equals 2x minus 1. I am going to then plug in 2x minus 1 for the y in the second equation. And you can see here what the result. So now that we've placed notice we placed the parentheses around it. It's really important that you do that to remind yourself that you substituted the 2x minus 1 in for the y in the second equation there. So now we can then distribute the 2, and we get 4x plus 4x minus 2 equals 12. And then we're going to combine like terms and then add 2 to both sides. And then we get x to be 7/4. Yeah, it's not very pretty, is it? How can we check? Well, we're going to plug in 7/4 into both equations here. Okay, and so we get negative 2 times 7/4. That gives me negative 14 halves. Or I'm sorry, negative 14 fourths, which is negative 7 halves, plus y equals negative 1. Well, then if we add 7 halves to both sides, we end up getting a y equals 2.5 or 2.5, 5 halves. So then let's plug it in down here, and we get 4 times 7/4. Well, 4 times 7/4 is 7, plus 2 times y equals 12. So if we subtract 7 from both sides, we get 5 over here. We get 2y equals 5. When we divide both sides by 2, we get y equals 5 halves again. So we know we did it right. So our solution to this is the point 7/4, 5 halves. If you wanted to do a triple check, if you had time, okay, you could rearrange both of those into slope-intercept form and graph them and use the graphing method to double check your answers as well. Now with the graphing, they will definitely give you the decimals, and so you have to be able to convert back and forth. Now, would that be the most efficient to graph this? Probably not. Considering both equations are in standard form, you don't want to graph those if they're both in standard form. It's just not efficient to do that. And remember, I'm going to be teaching you 3 different methods for solving equations, and you want to use the most efficient method, not necessarily the one you like the most, okay? Because time is of the essence, and that's why we have different tools for different problems. So you want to make sure you're learning all of the tools. The other tools can be there as a check or a backup if you think you're doing something wrong. But again, you want to be efficient with things. Your tests, as always, are going to have a time limit on it, and so you can't take 4 hours to solve problems because you only like to graph when there are so many other methods that will get you to the answer much quicker. So you want to make sure you're doing that and practicing all of the different methods as we get them. Let's go ahead and try the next 2 quick checks. I know sometimes we do the quick checks in class. Go ahead and pause the video here. Try the 2 quick checks, and then I'm going to show you the answers now, and you can check your work. So if we look at the 2 quick checks here, we end up getting x is 3 and y is 6 for this first one. Notice how easy this was for substitution because this first equation is set up in a y equals format. So we just plug in 2x anywhere we see y. The big thing is we have to watch our signs and then we can solve. Over here, this one required a little bit more work. Depending on which variable you would solve for, in this case, I would probably solve for a positive y. So it's gonna require, and I would rearrange a second equation. So it's gonna require a little bit of work, a little bit of patience, and a little bit of time. And we get x is 23/10. And I leave all of my answers in improper fractions. It's okay at this point. I know most of you are very comfortable converting fractions back and forth from improper to proper. It's just easier to work with if they're improper rather than mixed numbers, okay? So, and then we get y is 8/5 here. So those are the 2 answers to the quick checks. If you have any questions, we can talk about it in class tomorrow. Let's look at the second example because this is a word problem, and this is where substitution would come into play. So we have a class of 26 students going to the zoo, 5 chaperones who can each drive a car or a van. Each van seats 7 people, including the driver, and each car seats 5 people, including the driver. Okay, so how many vans and cars will be needed? Well, the first thing is we only have 5 vehicles, right? So the number of vans and the number of cars has to equal what? This is kind of that duh statement when we're writing our equations. Our cars and our vans have to equal 5. So that's going to be our first equation. Vans plus cars equals 5. And you can put in V's and C's for those 2 variables. Now, how many people would we have total? This is another trick of this problem because we have 26 students, but you notice the number of people in each one has to include a driver. And since we have 5 chaperones, technically we have 31 people that we have to fit into a van or a car. So my second equation here, let me show you my second equation. My second equation, there's my first equation right here. Vans plus cars equals 5. My second equation has 7 times the number of vans, because that's how many people there are, plus 5 times the number of cars, and that's going to be the number of people riding in cars, the total number of people, including drivers, and that's going to equal then the total number of people, not just students, okay? So in this situation here, I would definitely rearrange my first equation, and you could rearrange it into cars or vans. I just simply rearranged it into cars. No particular reason why other than that's what I did. If you rearrange it into vans, it will give you the same result. Don't panic. You'll get your answer for your solution for vans first and then have to plug that back in. So we can look at, there's the number of cars. If we then plug it into the second equation here, we put in the V or the 5 minus V in for the cars. And we get 7V plus 5 times the quantity, 5 minus V equals 31. Distribute, watch your sign here, combine like terms, and then solve for V, which is 3. So if we have 3 vans, remember back up here we said, well, 3 vans plus the number of cars has to equal 5. So that tells me I need 2 cars, okay? And then I can double check this by the number of vans times 7 is 21 plus the number of cars is 2 times 5 is 10. So 21 plus 10, guess what? That equals 31. And so that's my quick check there for that. And no need to graph. Again, we've got the numbers here and you can see how efficient that was. Please make sure you've checked the skills before you finish up this lesson in your notes. And also make sure you've finished your graphing homework from the previous class. Have a great day. I'll see you tomorrow.